It's not really good.
Yeah,
Just do minus 7
it's
camera
not
tutorials.
like what we know.
Like second grade, and it's like you tell me when.
Please state your
Yeah,
name
well.
from
The
Walking stuff is hard.
Pythag theorem. What kind of triangles you should deal with?
Right triangle. Right.
Wow, nice.
left.
Very interactive.
Yeah, very interactive. Haley will be so proud. So typically, we label the triangle with the sides A, B, and then C as the hypotenuse. C does not have to be the hypotenuse though. It's just in this case it is. And for the Pythag theorem, C is the hypotenuse, and so that's typically how we remember it. And so with the Pythag theorem, we're not going to go through the proof behind it, but the proof behind it, the way they figure this out is they use the concept of the geometric mean being drawn from the right angle here, okay? And being drawn to here, the altitude, and so they use the geometric mean to come up with the Pythag theorem. You don't need to know that, but what you do need to know is the Pythag theorem says the square of the legs added together is equal to the length of the square of the hypotenuse. So a squared plus b squared is equal to c squared. The letter C, though, only applies to the hypotenuse in this triangle. Another triangle, C could be one of the legs. So it just is all based on a leg squared plus a leg squared is equal to a hypotenuse squared. That's the key to remember. Okay, so with that, if this was A, C, and B, then you'd have to change your letters so that the hypotenuse squared is always the singular one. The legs squared are always added together. Right? We have different types of triangles called Pythag triples. I have a list of them over here. Taped to the wall, that's fine. Pythag triples, where you do not need to memorize these, but people memorize some and they recognize them. Pythag triples, has anybody heard of a Pythag triple? Okay, gold bar, done, a few people have. A Pythag triple is simply whole number values that work with the Pythagorean theorem. And so there's a list over here, a bunch of them. And so most of the ones that we end up dealing with are this. The three, I'll draw the triangle first and say this is a 3, 4, 5. Okay, so a 3, 4, 5 triangle, we check to see if it actually is a right triangle. If it's a right triangle, it'll fit the Pythag theorem, it'll work for the Pythag theorem. If it wasn't a right triangle, then it wouldn't work for the Pythag theorem. So we take a leg squared plus a leg squared is equal to a hypotenuse squared. So 3 squared plus 4 squared is equal to 5 squared. And that's 9 plus 16 is 25. 25 is equal to 25. Is that a true statement?
Yeah.
Yes. So what I have there is, this is what we call a Pythag triple. The Pythag triple, I'll move it up here. The Pythag triple is a 3, 4, 5 triangle. You know those measures make a right triangle. Where what number would always have to be the hypotenuse? When we're dealing with triangles, what number is always the hypotenuse? The largest number is always the hypotenuse. So a 3, 4, 5 is a Pythag triple. If you look at the sheet up here at any point in time, the next one they list is a 5, 12, 13. The reason, there's other ones that work, but they don't list the multiples of the 3, 4, 5. The multiples of the 3, 4, 5, if you multiplied it by 2, would be a 6, 8, 10. Yep. And then if you multiplied it by, 3, it would be a 9, 12, 15. Those are all Pythag triples. The other one that we see fairly often is a 5, 12, 13. I'll write that up here, 5, 12, 13. After that, there's an infinite amount of them, but you usually don't want to memorize many more than that. You don't need to memorize any of these. They can just help if you saw a triangle, for example here, if you saw a triangle that looked like this and it said, oh, I have a length of we'll just do this, it's a 5 and then this is a 13. Sometimes people can recognize without doing the Pythagorean theorem they can say, well, it's a right triangle, this hypotenuse 13, this is 5, what do I know this length has to be without doing the Pythag theorem? It's going to be a 12 because it's one of our Pythag triples. Pythag triples don't deal with decimals or fractions, it's just the whole number values that make up right triangles. Some people like to know them, they like to memorize them. The 3, 4, 5 comes up quite a bit. You can recognize that one. If you really want them to memorize a bunch, they're over here. You can memorize a bunch of them, you can look them up online. No need though. Okay? So those are Pythag triples. Again, a Pythag, a right triangle, the hypotenuse is always the longest side. So keep that in mind. Let's do some examples here with the Pythagorean theorem. Find x. Yeah, isn't it cool? Yes, it is, Dom. It's funny. Enjoy it.
I don't find it very.
It's the small things in life.
It's huge.
It's not funny. Feeling like small things. Oh yeah.
That's what it's
Very not funny. I'm just gonna leave.
like. You go sit at people with yelling.
This is great. I actually hate this guy.
Yeah. Wow. It's not bad. It's not like the chalkboard.
You were trying to write.
I see your product.
Oh, we need to put some units on it. Good, good, good.
I'm gonna leave.
You're gonna mess up the marker.
Yeah, I feel bad for the market.
Okay. All right.
Jams them. The snobs are bored with them. Just like,
Who does?
they're just beating your markers.
All right. Well, go ahead and find out C or find X, and then check with your cheat mate to see what you each get. What are you doing? Sit down, Dom. Sit down. Dom, give it to Gold Bar. He'd love some.
Wait, everyone's getting water. What are you doing?
Yeah, who knows? But
Honestly.
Mouth germs all the way.
yeah.
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 Y'all have those stairs. I can just buy you.
So why don't you go simplest radical and simplest or decimal to the nearest hundredth?
I really like this scale because you're saying changing those origins and I have 15.
Simplest radical and then nearest hundredth. We should be nearing completion.
Almost there.
by 2015.
2015. Well, there are stairs.
Where'd you get these?
How many were saying?
Those were
No, they weren't. In the
They were
box.
too, yeah, the
Oh,
box.
somebody must have snuck them in there, along with the nasty cheese.
They're good.
No, they were in one of those like baggies.
Oh, they were in a mystery bag? Oh, no way.
Oh,
You never know what.
All right, so for number 1, we set it up. Chris, what'd you set up?
7 squared plus 4 squared
Yes.
equals x.
Yeah.
All right, so you got 49 and 16 is?
65.
So then simplest radical would have been, right? And then decimal,
8.06.
8.06 meters.
Yeah, meters, that's what I meant.
I don't know why it's so funny to me. All right. Gold bar, what'd you do for the number 2?
I didn't get number 2.
Okay, Dylan, what'd you set up?
What I set up? So, x plus 15 squared.
X plus
15 squared.
X what, guys? X squared.
Plus 15
squared equals 25 squared.
That's fine.
Yeah.
Okay, now some people make the error and they take like the square root right away. You can't do that, right?
No, you
Because it's attached with addition. So you just want to isolate the squared and then simplify. So this is 625, 225.
And I just subtracted over.
So right over here, x squared plus 225 is equal to 625. So x squared is equal to 400. So x is equal to
20.
20. So what I see here is that I have a 15, I have a 20, and I have a 25. Would that be a Pythag triple?
Yes.
Because it's whole number values. So they call it a Pythag triple. If you look over here, you do not see it in our Pythag triple list. Why not, Riley? We got 15, 20, 25. Why is it not
Oh, we need
listed?
to reduce it, that's why.
Okay, Taylor? Yeah, it's a 3, 4, 5 or multiple thereof, right? Now you don't need to say that, but just making a note that, oh, it's a Pythag triple. You could have recognized that possibly, that it was going to be that, but this is a multiple of a 3, 4, 5. So, as a side note, Riley.
It seems to work if you take the square root of the number that can be square rooted and then add it to the other leg. So the square, in this case, the square root of 25 plus 15. It seems to work on every triple that I've seen.
Okay, what do you want to do?
So take another triple, for instance, 3, 4, and 5. You can just take the square root of 4, which is 2, add it to 3, you get 5. And that seems like a lot easier way to work. I'm wondering if it works for all of them, if you did it that way.
That's okay, 11, 60, and 61.
Oh yeah, that's true.
But that's interesting that worked. Did it work for, it only worked if the middle number was a perfect square. Right?
Yeah, because it won't work for 15, 20, or 25.
Yeah, it would.
A
Just
9,
take the square root of 25, 5 plus 15 is 20.
But you said to take the square root.
So take the square root of the middle number.
I like your thinking though, the fact that you're even thinking about that is interesting, it's good. But, it doesn't hold true.
Thank you, man.
What happens if you have a maybe not is. How about do the sides make a right triangle. Now I'm going to tell you on the quiz, on the test, you're going to have to show yes or no. You won't just be able to write yes or no. This is number 3, I think, right? So you have 20, 30, and 40. And then we'll do number 4 here is 4.5. I'll move out of the way in a second. Ian, 6 and 7.5. So you can't just write yes or no. You have to show by doing the Pythag theorem to see if it works for the Pythag theorem. If it doesn't work, then it's not a right triangle. If it does work, it is a right triangle. But you cannot just simply write yes or no. I won't give you any credit. So I know some of you might miss this on the quiz. You don't have to. You just want to show. So you do the Pythagorean theorem and see if it works.
Is that it?
So you go 20 squared plus 30 squared equals 40 squared. You're going to see if it works. If it does, if the left side equals the right side, then you know you have a right triangle.
Yeah, Pythag.
So you have a 1300, right, is equal to 1600. True or false?
False.
So therefore, no. Because 20 squared is 400, 30 squared is 900, 40 squared is 1600. So go ahead and do that for the next one. And you always know your biggest side is your hypotenuse. That's the one that stands alone.
So the right side has to equal the left side.
Left and right have to equal if it's a right triangle. It can still be a triangle, just may not be a right triangle. It's a wrong triangle.
That's the wrong.
It's a left.
It's a left. It's a left.
It's a left triangle. What do we get on the left-hand side?
4.5 squared plus, wait, you're talking the formula?
Yeah, what do we get for the value?
Oh, so you gotta redo it again.
What?
56.25.
56.25? So therefore, yes, that's how you do it on the test. Okay, I'm going to set you the task here in a second. Well, the only thing I wanted to make a note of is if you have a isosceles triangle, okay, what we know is the sides are the same. You have to remember that, right? And then if you have an altitude drawn, what does the altitude do to the base here?
Cuts it in half.
Yeah, it cuts it in half. So, right, so some of those things are going to come into play. If you have what shape does this look like?
Parallelogram.
Parallelogram, check. What else?
Rhombus.
Rhombus. What do we know about a rhombus?
All sides are equal.
All sides are the same, and then what do we know about the diagonals of a rhombus? They bisect, sure, they bisect. What else do we know?
They're perpendicular.
What?
Perpendicular bisect.
They're perpendicular. So therefore they intersect at a 90, making what kind of triangle here?
A right triangle.
Right triangle. So you'll see some of these shapes that you have to navigate, and it's like, well, they don't give me a right triangle, but wait, they do.
Nice.
Nice.
I like it.
Okay.
You're not gonna